with part 3 of the Python for Researchers, Pandas and Matplotlib mini-series, day number 3. So, this is what we did yesterday. We generated our graph. It looks okay, I think. It's a bit meh. I think what I'd like to do is jazz it up a bit. So, over the next 10 minutes, we're going to make the figure a bit bigger. Let all that data breathe a bit on the page, and we'll have to change the sizes of the labels and the title accordingly. We're going to change the X scale so that there's no gaps here, so my lines actually touch the edges of the chart. I think I'd like some grid lines on there. I'll put some grid lines on, and the most important thing I'm going to show you is how to then export that as a vector graphic or as an EPS file. And that's really important for when you're submitting your figures to publications and even your theses, that your images look good no matter what resolution you try and view them under, okay? Right, so to begin with, let's define two new variables called, say, height. I'm going to use 10, and a width, and I want the width of the image to be 2/3 of the height, and to implement that within the subplots command, I use this extra parameter fig size equals, and do width and height. Whoops. And if I run that, there you go. My image is immediately bigger. So I've got a lot more white space in. I think it looks better, but what I did mention is the label size now is just too small. You're going to get criticised for that if you, any reviewer in their right mind would say text too small on your images. Okay, so we'll do something about that now, and that's really easy to do. We just look at all of the points where we've set our labels, and we're going to type parameter font size. I'm going to use font size of 18, nice and big. Do that for all of them. Font size equals 18. One more time. And I'm also going to change the font size of the legend as well. Font size, and I'm not going to use 18, I'm going to use 40. I think 18 is just too big. Let's run that. There you go. Matplotlib decided my legend's better off down on the bottom right this time, but that looks a bit better. What's a bit annoying is my actual tick labels are quite small now, my label size, so I need to do something about that. That needs an extra line, and the line to include is ax.tickparams. And just to confuse things slightly, I'm not going to use the word font size, I'm going to use the word label size. There is a good reason for that in Matplotlib. Actually, I'm not going to go into now, but I'm going to use a label size of, I'm going to use a label size of 16 to distinguish it from the actual axis labels themselves. Let's run that, and there you go, that's much better. Problem down here is, now I've changed that font size, the labels all overlap, which is no good, is it? There's a very good reason why these labels are overlapping. Let's take a look at our data frame again. So if we go back to our old friend df filtered, and we look at the column values, they're all strings, right? And Matplotlib doesn't really handle strings very well. It much prefers it if you can use integer values for your x-axis, because it will then automatically space them out in a nice way. So let's convert all of our data table column, or our column headers, as integers instead of strings. Okay. Now to do that, I'm actually going to call this and define a list called years. Let's run that. And then I'm going to use this. I'm going to redefine df filtered columns as, I'm going to use this list. It's got to be a list. I'm going to use the map function. I'm going to map integer to all of those values in that list. So I'm going to make them all integers. And if I run that, and we take a look at that column again, okay, they are now all integers. So if I go back up here and I run this cell one more time, my x-axis is now much improved. I'm sure you will agree. Okay, that's a very nice trick of Matplotlib. Is as long as you're using integers for your axis labels, it will try and space it out in the most aesthetic way it can do. Brilliant. And it's also chosen to put this back in the top left. Don't know why. I don't know why it's done that, but it looks better, I think. Right. What else do I want to do? I wanted to change the x scale slightly so that these lines touch the edge. So I wanted to find a new x range. I'm going to go from 1500. And I know the last x value in here is 2012. So I'm going to do that. And that's, again, really easy. Do x.set xlim 1500 to 2012. And I can use integer values now because I've reset those column labels. So let's run that. There you go. That looks a lot better. And the last thing I wanted to do, I wanted to show you how, now you've done all that, to get this out as an EPS file. So let's take our figure object, which we've called fig, and I'm going to use the save fig command, pretty self-explanatory. Let's give it a file name, world population. I'm going to use the extension EPS. It's an encapsulated PostScript, and you also have to specify that for, even though you've put the extension in there, you have to specify the format, EPS. And I'm going to run that, and then I'm going to go over and check out my notebook directory, and there it is, world population EPS. It's going to download, and there you go. Without one last thing I want to show you that you might want to use depending on how you're writing your publications and your thesis. So I use LaTeX. I love LaTeX. I think everything looks better in LaTeX. Some people disagree, but if you want to have a font which is consistent with your LaTeX text, you can change the font here to match that. And to do it, you need to use 2 lines. So let's go back. And I need to do it right at the beginning of the plot. Or you can even do it right at the beginning of the notebook. I'm just going to put it here. And you've got to write plt.rc text as a string. And then I'm going to use the parameter use tech equals true. Oh, capital T. And then I'm going to do plt.rc. And this time I'm going to use the word font. And I'm going to write family equals serif. So it's worth remembering those two if you want to have a LaTeX font. If I run that, you can see it's now in glorious LaTeX. Brilliant. And if I save that as an EPS, it's ready to go into my thesis or a publication. And that's it for today. Tomorrow we're going to take this graph, which I think is looking pretty good now, and we are going to make it interactive using Plotly. So more about Plotly tomorrow. Something which I think is amazing and really, really allows you to share interactive graphs on the web. I'll see you tomorrow. Have a good evening. Forgot to put the bloody grid lines on. Right, here we go. This is really easy. I'm going to do it down here. ax.grid. And I'm going to use the parameter which allows me to specify whether I want the major or the minor grid lines to be formatted. I'm going to do the minor first. I'm going to use a line width of 0.3, and I want the color to be a nice grey. Okay, I don't want it to be black. It's a bit too much. If it's black, I'm going to use grey. And if I run that, immediately I've got some minor grid lines. Okay, how about the major grid lines? So ax.grid which equals, major. I'm going to put a heavier weight on there. And again, color equals grey. Okay, so there you go. That looks a bit better. Personally, I don't like the major grid lines on the y-axis. Okay, I think it looks a bit too busy here. I don't like as well. There's like this. You got this last grid line at 2000, and you got an extra bit of white space here. That annoys me. I don't know why. You might feel different. You can keep them if you do, but I want to get rid of those y grid lines on the major. So I just do axis equals y there, and they disappear. Okay, so that looks better. Right, I'm done. I promise. See you tomorrow.